Hello everyone. Today we are going to discuss the last topic of this chapter, and today's topic is cube roots. So what are cube roots? Just like we have learned about square roots, similar is the case of cube root. So let us see what are cube roots. Finding the cube root is the inverse operation of finding a cube. Yes, just like as I've said a while ago, just like finding the square root is the inverse operation of finding the square, similarly, finding the cube root is the inverse operation of finding a cube. It is just the opposite case. Say for example, 2 cube is 8. So what can we say from here? That 8 cube root will be 2. It is just the opposite operation. Now how do we denote this cube root? We write cube root of 8 equals to 2 in this way. So this symbol, it is just like a square root, but along with it there is a 3 in front of it. Clear? So this symbol denotes cube root. Now next, how do we find the cube root? But before going to that, one important thing I would like you all to notice is that this is given directly from your textbook. Now you might be thinking this is very well common that 1 cube is 1, 2 cube is 8. But what I meant to say here is, if you look carefully, it follows a pattern. Now what is this pattern? Now you see here 3 cube, 1 cube is okay, it's 1, 2 cube is 8. But whenever the number increases or the number of digits increases, then we have to follow the pattern by looking at its ones place or the unit place. So if you see carefully, 3 cube, the unit place is here is 7. 4 cube, it's 4. 5 cube, it's 5. 6 cube, it's 6. 7 cube, it's 3. 8 cube, it's 2. 9 cube, it's 9. 10 cube, it's 0. So have you seen anything common here? No. All of them are following some different pattern. Similar will be the case if we go on with the higher order numbers. Say 11. There also, since 1 is there in the unit place, so the resulting cube also will be such a number whose ones place will be 1. You can check it out for yourself also. Similar will be the case for 12, where the last number would be ending with 8. So in this case, there is some pattern being followed. You can check that as a practice by yourself, and you can find out that it really works. Okay then, now moving on, as we have been discussing a while ago, that how to find out this cube root. Now one of the easiest method which is generally followed, and especially for smaller numbers, so that is the cube root through prime factorization. Now this is almost similar to that of square root, but just in the square root we were finding out some pairs of numbers. Here we will be finding out some triplets of numbers or triples, which we say. So say for example you are given a number 3375. Now if you are asked to find out the cube root using the prime factorization method, then it's very simple. What we need to do is we have to first of all find out the prime factors. Then we have to arrange them in triples in this way. 3 is arranged as triples, 5 is arranged as triples. Now this whole triple can be collectively said as 1 unit. That is 3 to the power 3. We can write it in this way. And 5 to the power 3. Because 5 is occurring 3 times. Clear? So collectively what we can say as 3 into 5 to the power 3. Whole to the power 3. Clear? because both of them are having the same power. So we can do this. So therefore the cube root will be what? Cube root will be whatever is inside this. That is 3 into 5, that is 15. 15 cube gives us 3375. Or we can say that in inverse way, that cube root of 3375 is 15. Clear? Now there is also some other methods for finding out the cube root. Now this method is called the estimation method. So let us see what is this method. Cube root of a cube number. Now this method follows 3 simple steps. So let us see. Say for example you are given a large number like this. Then what to do? Here if you try to find out through prime factorization, although you can, but it would take a much longer time. Then what to do in this case? Here we have to use estimation method. We have to guess out that what could be the possible cube root of this number. And for that what we need to do is, first of all, in the step 1, we have to break this number into groups. Here we have done it in groups of 3. 3 and here 3. Now we'll be discussing what if the number is a little bit smaller number. We'll come to that later on. But here now we have to first group it. We have grouped in 3. But the grouping will start from the rightmost end. So the rightmost end is here 5. 5, 7, 3 will be grouped in one group, first group. And 7, 5 and 8 will be grouped in the second group. Clear? Now after that what we have to do is we have to now estimate, taking one group at a time. So if you see in the first group, the digits that we have here is 5, 7 and 3. Now as I have told you in the earlier slide, that for finding out the cube root, we have to know the pattern. That is very important. So if you remember it correctly, then the number here ends with the unit place 5. So taking that unit place into consideration, what we do here is the number, as you can see here, the number 375 ends with 5. Now we know that 5 comes at the unit place of a number only when its cube root ends in 5. Yes. Whenever the number's cube root ends in 5, only then the unit place of that number ends with 5. Clear? So we get 5 at the unit place of the cube root. Even in the cube root also we will place 5 in the unit place. So this is confirmed now. Now next we have to find the other digit. For that what we need to do, we have to go to the second group. Now in the second group what we need to do is, we have to see 857. Where does this number lie in the cube roots or the cubes list? Now we know that 9 cube is 729 and 10 cube is 1000. So it lies in between this. This number lies in between 729 and 1000. Now what we need to do is, here also we have to take into consideration the concept of unit place. Now here we will be taking always the smallest number. So the smallest number here is 729. Now here what you see is, here the unit place of this number 729 ends with 9. Now if you remember it correctly, it would be such a number whose unit place will be 9. Only then its cube root will end with 9. If you remember it correctly. Then as a result we will take this 9 as our required number or the required digit. So we got our cube root, that will be 95. Earlier we got 5 and then we have taken now 9. So it is 95. So it's all about estimation and following that pattern. So if you can even calculate it by manually, that 95 cube will be this number. Or if you take the cube root of this number, it's just the inverse thing. If you take the cube root of that number, we will get 95. Now coming to the point that what if this number is a little bit smaller? What if it can't be grouped? Or what if here there are 6 numbers, so we have grouped them in 3 and 3. But what if there is some number which is little bit smaller than this, and what if there is not possibility of grouping them into 3 and 3? Okay, that's also not a big problem. Say if there are 5 numbers here, so we'll be grouping them as usual 3, and then the next 2 numbers will be grouped. So nothing much difficulty in that. Even if there are 4 numbers also, we can group them 3 and 1. Clear? So there are some upcoming problems given in your textbook where such a case arises. So the procedure will be as it is, no matter if the numbers are smaller, or no matter the grouping is not 3 by 3, it may be 3 and 1, 3 and 2, whatever it is. And if it is just a 3-digit number, then it's much better to do it with prime factorization. Smaller numbers, I would prefer you to go with the prime factorization method, not this estimation method. Clear? If it is a large number, then you can estimate it. So I hope you all have understood this. We have come to the end of this chapter. So I hope you all have understood the concept of cubes and cube roots properly. So you can again try this out, these methods, both the prime factorization and this estimation method. There are few examples given in your textbook. You can try it out for yourself again and see for yourself whether you can understand this concept and apply it by your own, by solving different kinds of problem that is given in your textbook. So that's it then for today. Thank you and have a nice day.